Hello guys and welcome back to my channel, and today we're gonna solve another important question for technical interview, and today's topic is dynamic programming. And the question that we will be solving today is finding the minimum cost path in a given matrix. But before that, if you like this video and found this video useful, please do like and share this video. And if you're new to my channel, don't forget to subscribe to my channel and hit the bell icon so that you never miss an update from my side and you're always ready for your next interview. So let's start with the video. So before solving the problem, let's first understand the problem. So given a matrix over here which denotes nothing but the cost of traversing between 2 points, we have to calculate the total cost of traversing from the start of the matrix, that is from over here till the end of the matrix. Which means that we have to find out the minimum cost of traversal from start till the end. So over here, if you see that from the starting point of our matrix, we can travel to the end of this matrix by various paths over here. We can easily take the outermost edge from here, otherwise we can take the outermost edge from this side, or we can easily take some intermediate path from here. So there can be many paths by which we can travel from the starting point of the matrix till the end point over here. But the thing is that there is only one constraint for this traversal. That is, we can either traverse to the right hand side or we can traverse to the downward side. Which means, for example, at position 1, we can either traverse to this direction or we can traverse downward. But we cannot take the diagonal path over here. But during the interview, if your interviewer changes the question that instead of taking only the right and the downward path, you can also traverse diagonally, I will also give the solution of that problem at the end of video. That is a small modification to our existing problem. So let's first see that how we need to find out the minimum cost of traversing. So over here, if you see that if I take this outer edge for traversing from the start till the end, the path that we will be covering over here is 1, 3, and the total cost of traversing from the start till the end will be 7. Similarly, over here, if I take this path, that is this outer edge, the path of traversing will be, the cost of traversing will be 9. In this way, there can be many paths by which we can travel from start to end. And over here, we have to find the path which costs us the minimum value from start to end. So over here, if you travel through each and every path, you will find that this path, which is cost 7, is the minimum of all the paths that we can accomplish over here. And thus, we have to calculate this value over here to get our answer. So hopefully you guys have understood the problem and you got a complete knowledge of what is the required statement or what is the required goal that we have to solve in this problem. So now let's solve this problem using the dynamic programming. So as in our previous video, I have already told you that there are only a few patterns by which you can easily solve any dynamic programming question. And this problem comes on the pattern 6 of our dynamic programming. And the way by which we will be solving this problem is by using an additional data structure, that is the memorization table, which is nothing but our approach of solving the problem using the bottom-up approaches. To solve this problem using bottom-up approach, we will first create a matrix of similar size. And let's call this matrix as DP. So as we are starting from the first index over here, you can see that the cost of traversing to the first index is 1. So we will blindly put 1 on the first coordinate over here. Now you can see that in the problem it is already mentioned that we can either traverse to the right or we can traverse to the downward direction. So we will first calculate the cost of traversing to the right. So over here you can see that the cost of traversing to the second index, that is over here, is 3. Which means that if I want to traverse from here to the second position, the total cost of traversing will be 4. Which means 3 plus 1, that is equal to 4. Similarly, if I want to traverse from here till this point, the cost of traversing will be 3 plus 1 plus 1, that is 5. Since there is no other option than to traverse only in one direction, that is still to the right, we will be simply summing up the value over here. Similarly, over here, we will calculate the cost of traversing in the downward direction. So over here, you can see that the cost of traversing to the second index over here is 2 and the cost of traversing to the third index is 6. So we are already done with the initial setup of dynamic programming. We have already calculated the cost of traversing on the right side and the downward side. Now we have to calculate the cost of traversing from here till the end of this matrix. So what we will be doing is we have to first calculate the cost of traversing of this index. So over here you can see that the path by which you can traverse to this index is either by using this path, that is 135, or by using the second path, that is 115. But over here if you consider the cost of the path, that is 115, is minimum. So over here if you see that between 2 and 4, 2 is the minimum. Thus we will take the minimum of these two, that is 4 and 2, and we will add the corresponding value of traversing, that is 5, over here. Thus the cost of traversing to this point will be 7. I hope this is clear. Similarly, we will calculate the cost of traversing till this. So over here you can see there can be many paths by which we can traverse. So we can traverse by taking this path, or we can traverse by this path, or we can traverse by this path. So the easiest way of calculating all these three parts is we will just compare the two associated value, that is this one and this one. So over here to find out the value of this coordinate, we will see that which is the minimum of 7 and 5. So over here we can see that the minimum cost of traversing until this point is 5, and thus the cost of traversing will be 6. And similarly we will calculate for this one. So over here the cost of traversing until this point is 6, which is the minimum, and thus we will add 2 over here, thus it will be 8. Similarly over here to find out the last position, we will check the minimum of this 2, which is 6 plus 1, that is 7, and thus this is our required answer. So over here you can see that 7 is the minimum cost of traversing from the starting till the end, which we have already proved over here. And the path by which we are traversing is, we can easily find out by calculating backwards by finding the minimum of the two. So over here you can see that the minimum of this 2 is 6. After that we will again calculate the minimum of this 2, that is 5 and 7. Again we are calculating the minimum of this 2, which is nothing but this. Thus the path we are taking over here is 13111, which is nothing but the outer circuit over here. So I hope the solution is quite simple and easy to understand. And believe me, since this is a simple logic, the coding of this problem is also quite simple. So let's implement the solution using our Java code so that it will be easy for you to understand the solution. But until now, if you have liked this video, please do like and share this video. And if you are new to my channel, don't forget to subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's start with the implementation of this dynamic programming, and let's see how we can find out the cost of minimum traversing. So let's name the function as minimum cost path. So over here as a parameter we are sending the actual array and we are sending the size of the matrix. So as we have discussed that since we are solving this problem using the bottom-up approach, we have to initialize a matrix having the same dimension, which we will be using as a memorization table, and that is why we will be declaring a matrix over here. So let's declare a matrix. Now since we are done with the initialization of our DP table, that is our memorization table, now let's start filling up each and every position of our table and let's calculate the minimum cost of traversing. So the first and foremost thing that we have to do is we have to travel this matrix, that is the given matrix, from the start till the end over here. And for traversing we will be using the to for loop. So as you know, since this is the starting point of our matrix, we simply have to put this value over here. So over here we will start filling each and every position over here and we will keep on calculating the minimum cost of traversing. So over here you can see that since this is the starting point of our matrix, that is 0, 0, we are simply putting the value of this matrix, that is 1. Now the next thing that we have to compute is we have to compute the corresponding value of the first row and the first column of our memorization table. And for that we will simply sum up the previous value with the current value and we will create the memorization table. So over here we have simply computed the first row and the first column of our memorization table. So after the first iteration, our memorization table will look something like this. Now the next step is we need to compute the minimum cost of traversal for the rest of the table. And for that we will be using the formula like mean of this two plus the value of this index. So let's write the formula. So over here you can see what we are doing is we just are checking the minimum of these two values, and based on the minimum value we are just adding the value with the cost associated in this index, and thus we are calculating the cost of traversal until this point. And at the end we will close our for loop and we will return the value of our final table. So I hope the way we have solved this problem is pretty easy and straightforward. So if you have any problem regarding understanding the problem, please let me know in the comment section below. And I will also share the same code in the description below. Please feel free to go through the code and try to understand the solution completely so that it will be easy for you to understand the solution. And one more thing that I already told in the beginning of the program, that if the interviewer changed the problem by telling that you can travel to the right hand side, the down side, as well as you can do the diagonal movement, at that time you simply just need to calculate the minimum of these three index. And after finding the minimum of 2, the approach will be same. So hopefully you have understand the solution thoroughly. And if you have liked the video, please do like and share this video. And if you are new to my channel, please do subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So let's proceed with our next problem. See you on the next video. Thank you.